Good afternoon. Let us start question 51. Effect of temperature on spontaneity of reactions represented by. That means temperature effect is working. So according to delta G principle, delta Z is equal to delta H minus T delta S. First one, plus and minus, plus H minus of T into minus S, minus plus. That means here no effect of temperature, because at any temperature it is always positive value only. So no effect. Second one, plus. Delta Z is equal to delta H plus minus T delta S also plus. So that means this is minus T delta S only. Now if T is predominant, then this T delta S predominant over the delta H will get negative sign. Okay. So plus, low temperature, spontaneity. So spontaneity working, but generally T predominant over delta H. That means we don't know delta H value. So we can assume that it is a spontaneous given means T delta S predominant over the delta H, even though low T present. If it is high T present, compulsory T delta S negative value. So the condition given spontaneous under the plus. So effect of temperature is working. Next to C, both minus. Delta Z is equal to minus H minus of minus S minus H plus T delta S. So minus H plus T delta S, that means if T delta S is small value, that is low T present, then delta H value predominant. But the condition here non-spontaneous. Non-spontaneous means if T delta S itself is a predominant factor due to high entropy change over delta H value. That means here also working of effect of temperature. Working of effect temperature. Next one, minus plus delta Z equal to minus H minus T delta S. It is always minus only. No effect of temperature. So effect of temperature working for B and C. Okay, but working okay is small effect of temperatures. Generally the given condition spontaneous means for both plus, that is this one, both plus. So T delta S predominant means delta S some constant value, delta H constant value, T delta S predominant factor. When T increasing, then this become compulsory negative value. So here requirement generally high temperature is best one. But there are no other options for effect of temperature. That is A and D no effect temperature, only B and C. Same here also. Minus H predominant over T. T is low. Low means this is small value, this is high value. That means spontaneous. So for this condition, this spontaneous condition correct one. Okay. So that means effect working for B and C only, but not for A and D. Okay. Next one, standard electrode potential of few half cells given here. Copper, zinc, silver, magnesium, all of them SRP only, redox potentials. Cells gives most negative value of delta Z naught. Delta Z naught is equal to minus NF E naught of cell. So to get most negative value of delta Z naught, E naught should be more positive value. If E naught of cell is more positive value, then positive into negative, negative sign. Delta Z naught becomes more negative sign. So first condition important one, that is more positive value obtained. E naught of cell is equal to E naught cathode minus E naught anode from SRP values, cathode minus anode, or E naught OP plus E naught RP, reduction potential plus oxidation potential, but given in terms of all reduction potentials. So that means, let us check which combination gives the highest value of SRP, that is E naught of cell. First option, take option wise. So when cell reaction is given, cell notation given, very easy method. Don't use this formula. This formula use. E naught of cell is equal to E naught OP plus E naught RP is simple, best method, because we know cell notation. So as for cell notation only, we have to find out the cell EMF. If cell notation not given, then follow this formula, cathode minus anode. So now left side anode, right side cathode. Left side everyone is anode, right side is cathode in the cell notation. So that means these all OP values, these all RP values. So first zinc and silver combination check. Zinc OP value means plus 0.76. Silver 0.8, 0.8 plus 0.7, 1.56. So this gives 0.76 plus 0.8. That is the highest, I think, 1.56. Next value, ZnOP magnesium RP, 0.76 OP plus RP value minus 2.37. It gives negative sign, but we want positive sign, means this is non-spontaneous cell reaction. So we don't want this one. Next, third one, silver OP magnesium RP, OP reverse minus 0.8 plus RP same minus 2.37. This also negative sign, non-spontaneous. Last one, copper OP silver RP. Copper OP value minus 0.34, RP of silver 0.8, just 0.36 only, around 0.46. So now which is highest value? 1.56 is the highest value. 1.56 is the highest value. Therefore, correct answer is 1.56. Because remaining values are 2 and 3 are negative values, non-spontaneous cell reaction. And fourth one is small positive value, 0.46 only. Therefore, correct answer is only option 1. Okay. Alpha helix beta pleated sheet structure of protein belongs to alpha helix, beta pleated. These words used in case of secondary structure of sequence of proteins. Primary is called sequence of protein arrangement, that is called polypeptide chain or amino acids. Sequence of amino acids to form polypeptide chain is called primary. Polypeptide chain arrange in the helix model and sheet model, that is called secondary structure of protein. It's a constant concept only. Secondary structure of protein, alpha helix and beta pleated sheet. Next question, 54. Consider the given below two statements. ROR plus H2O means hydration. This reaction is called hydration. Reaction is called hydration. To form ROHOH. Case 1, statement 1, formaldehyde suppose apply in the compound given is about 2280 K value. Due to small substituents of hydration is faster. Highest reactive is water molecule with formaldehyde only. Most stable hydrate is formed. I take H plus and OH minus is equal to H, C, OH, OH and H. This is most stable hydrate due to small atoms. Small hydrogen atoms. So this name is called formaldehyde hydrate. Formaldehyde hydrate. Second one, chloral. This is also stable, but this is the first one only, highest stable. CCl3 CHO plus HOH, this all same reaction, minus plus CCl3 CH OH OH. Here are two reasons. One reason is given already here. Due to strong minus I effect of chlorines. These three chlorines have strong minus I effect. So electrophilicity of carbon increases. That is why nucleophilic attack of water molecule takes place. That is one reason. And the second reason, most important one, existence of this compound, stability of this compound due to intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Minus effect is correct one because of strong electron withdrawing effect of CCl3. This becomes most positive charge. That is why nucleophilic addition of water molecule takes place to form stable hydrate. So it is also correct one because one of the reason given here and the value of given 2000 times. Stability increases means existing. That is why this is most stable, correct. 2280 is 2000. Correct one. Both statements are correct. Both true. 1 and 2 are true. Actually, these compounds, nearly 4 compounds only present as stable hydrates. This is one, this second one. Third one is called cyclopropanone. Cyclopropanone. And fourth one, ninhydrine. This name is called ninhydrine. This one react with water molecule to 2OH. Those two OH are joined by intramolecular hydrogen bonding with neighboring keto groups. So here reason same intramolecular hydrogen bonding only. Here reason strain decreases after ring opening, this double bond opening into single bonds, strain decreases. That is the reason for this one. So, if 4 compounds generally forming more stable hydrates only. First one is formaldehyde, second one chloral, third one cyclopropanone, fourth one ninhydrine forms stable hydrates. Different reasons. So, this is small atoms. So, this is strong minus effect as well as intramolecular hydrogen bonding. This reason only intramolecular hydrogen bonding only. This reason strain decreases in case of cyclopropanone. Okay. So, both are correct treatments. Next question 55. X2Y gaseous state into X2 gas plus half Y2 gas. The equation representing the correct relation between the degree of dissociation X and equilibrium constant Kp is. This statement important. Assume that X is to be very small. X is very small. That means 1 minus x or 1 minus 1 plus x is taken as 1 only. That is assumption meaning. Let us start the equation. X2y gives rise to x2 plus half y2 1 0 0 1 minus x x of x total moles equal to 1 plus 0.5x or 1 by 2x. Now come to Kp formula. Kp is equal to partial pressure of x2, total pressure P, mole fraction of x2, x by 1 plus 0.5x raised to 1 coefficient. Second one is total pressure into half x by 1 plus 0.5x raised to 1 by 2. Okay. Divided by reactant P into 1 minus x by 1 plus 0.5x. So, cancel first P 1 plus 0.5, cancel. Remaining terms check them. X raised to 1, P raised to 1 by 2, x raised to 1 by 2. This is root 2. This is taken as 1. So, denominator 2 raised to 1 by 2. Okay. So, next step x 1 plus 1 by 2, 3 by 2, P 1 by 2. This is Kp into 2 raised to 1 by 2. We want x value. You can multiply all the powers with 2. Then Kp raised to 2, 2, x raised to 3 into P. Therefore, x equal to Kp square into 2 by P cube root. So that is the final answer. X equal to cube root of Kp square 2 by P. That is 2 Kp square by P cube root of. That is option 2. Okay, so here 1 plus 0.5x taken as 1 because assume that x is very small. So 1 by 2 means 2 raised to 1 by 2, that is denominator. So powers multiplied with 2, then Kp square into 2 x cube P. So find the x value. Okay, so normal derivation only, just take the precaution about the denominator values of assumption 1 plus x, 1 minus x, that values. So here 1 plus 0.5x taken as negligible, but it is multiplication, don't neglect this one because 1 by 2 into x multiplication, 1 plus something that is x value given, then negligible as 1. Next one, 56th one, identify A, B, C in the sequence of below reaction. A, HNO3 lead nitrate, B, sulfuric acid. So first one, lead compound. In group 2 analysis, on passing H2S gas, use black PPT of copper sulfide or lead sulfide. Group 2 analysis. Practical or side analysis, group 2. Black PPT of PBS or copper sulfide obtained. So black PPT confirms it is a lead sulfide or copper sulfide, but question is for lead only. So it must be A, lead sulfide, that precipitate first dissolve in nitric acid. This is PPT, color black. This is dissolution to form lead nitrate solution plus H2S gas releasing plus H2S gas releasing. That means black lead sulfide is converting into colorless lead nitrate solution. Lead nitrate solution is adding with sulfuric acid gives lead sulfate, but PPT. Lead sulfate is a PPT, color white. Nitrate is not PPT. One rule is there, all nitrate salts are soluble, they do not form precipitates. All nitrates are soluble, do not form precipitates. That is why we can take nitrate solution but not PPT. Lead sulfate is a white PPT. Lead sulfate PPT is dissolved in ammonium acetate and acetic acid. These two common only, ammonium acetate and acetic acid. That is in presence of common and effect. Lead sulfate is converted to lead acetate. Lead acetate, PbCH3COO twice. Lead acetate solution. Okay. Lead acetate solution plus potassium chromate, K2CrO4. What is the reaction expecting here? Lead plus chromate to form lead chromate yellow PPT. Plus potassium salt of acetic acid. So what are the respectively compounds? Starting is lead sulfide, second lead nitrate, but second not given here, lead sulfate, B. Direct C, lead chromate. So PBS, PBS4, PbCrO4. Option 2. Next, 57th one. Statement 1, boiling point of alcohols and phenols increase with increase in number of carbon atoms. Correct one, because of van der Waals force increases. For respect to series of compounds, for alcohols, for phenols, increases molar mass, then boiling point increases. Boiling points of alcohols and phenols are higher in comparison to class of the compounds such as ethers and haloalkanes. Correct one, because they have hydrogen bonds. Due to hydrogen bonds, alcohols and phenols. That's why they have high boiling points. Both statements are true. Option 4 correct one. Because alcohols and phenols contains OH groups, they will form hydrogen bonds. So intermolecular hydrogen bonding, that is high boiling point. Ethers and haloalkanes do not contain. Okay. Next, when a non-volatile solute is added to the solvent, vapor pressure of solvent decreases by 10 millimeters. Mole fraction of solute is 0.2. What would be mole fraction of solvent if decrease in vapor pressure is 20 millimeters of mercury? This one PYQ question. No? PYQ, I think medical PYQ question. P naught minus P by P naught is called relative lowering of vapor pressure is equal to mole fraction of solute, is called Roots law. Relative lowering of vapor pressure is equal to mole fraction of solute is called Roots law. Now take the ratio of two comparisons, because P naught is a constant. For second comparison, P naught minus P mole fraction of solute second time. First time lowering is P naught minus P lowering. P naught minus P is called lowering of vapor pressure. So 10 by 20. First mole fraction 0.2. Second mole fraction of solute find out. 0.4. So mole fraction of solute second time is equal to 0.4. But question given find out mole fraction of solvent 0.6. Option 1. So just take the ratio for the lowering of vapor pressure for the two comparisons of first, initial and final. Next, 59, statement 1, for a given shell total number of allowed orbitals are n square. Correct one. Number of orbitals in a main shell. Number of orbitals in a main shell is equal to n square is correct one. For any subshell, spatial orientation of orbitals is given by minus L2 plus L including 0. That is also correct one. Spatial orientations or number of orbitals in a subshell or number of m values magnetic quantum number values is equal to minus L2 plus L including 0 is equal to total of a total of 2L plus 1 minus L2 plus L including 0, total value is 2L plus 1. So that is correct one. So both are correct one. Answer 3. Both are true. Number of orientations or number of orbitals or number of m values minus L2 plus L. Total values are 2L plus 1. The total not given, just range given. That is minus L2 plus L including 0 values. Correct one. Next, ascending order of relative rate of solvolysis. Solvolysis means SN1 mechanism. SN1 mechanism, that is through stable carbocation. Proportional to stability of carbocation. So just to convert them into carbocations and check comparison of stability. This is tertiary cation. This is secondary alkyl benzyl cation. This is secondary benzyl cation. This secondary aliphatic cation or alkyl cation. So secondary benzyl is more stable cation. That is called aromatic. More stable than secondary alkyl benzyl. More stable than A, tertiary alkyl. More stable than D, secondary alkyl. So increasing order D, A, B, C. D less than, A less than, B less than C. So if B name is called secondary alkyl benzyl. Any one side I can take. This is called secondary benzyl. Okay. So secondary benzyl is more stable because two sides benzene rings. This side one side benzene, one side aliphatic hyperconjugation only. Okay, answer 1 correct na? Next, ozonolysis product of following compounds. Just break double bond and first you take numbering easy to find out compound. I will take, this is for our convenient purpose, not IUPAC numbering. For convenience it is taken as suppose 1, 2, 3, 4, 5, 6. So break this bond 5, 6 and also 1, 2. So start here 1, 1. 1 is C, here no H, only O. C double bond O. 2. Also C double bond O. Here 1, 2, 3. 1, 2, 3. Okay, can take like this also. This side. Sixth one, aldehyde. Next 2 attached to 3. 4. 5 also aldehyde. 5 also aldehyde. 4, 3. So 2 aldehydes, 2 ketones first, number wise, 2 aldehydes, 2 ketones. But it is all of them 2 double bonds only. Check the number of carbon atoms wise. And cycles are same type. These 2 cycles, same size cycles. These 3. This is different. Now these are same size cycle only. Only place different one. Then how to find out fast means take IUPAC numbering of the full compound after reaction. IUPAC numbering wise, aldehydes termination group. We can start here number 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 1 aldehyde and 9th aldehyde, first last aldehyde. So almost all except last one. Next, second carbon ketone, aldehyde, second carbon ketone. Third, this is 4 times 1, 2, 3 plus 4, 7, 8, 9, 10. This is not correct. We want 9 only. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is correct one because aldehyde ketone fourth one. So A3. Next, break this bond, break this bond. I'll take same structure wise for B. Aldehyde ketone, CHO, ketone, this was ketone, this also ketone, methyl branch. Now take numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons here. Oh, because the branch in the chain also. This branch also in the chain. Okay, 10 carbons. 10 carbons we can take now. First aldehyde, last but methyl. First aldehyde, last methyl. So look here, first aldehyde, last. This is only one option having last methyl. B4. First aldehyde, last methyl. Next for C. I will read here for C. Start here. Double bond O ketone. This also ketone. Next, single bond. This is aldehyde. Next, that side. Bond, methyl, and this also aldehyde. Start from one aldehyde, number 1, 2, 3, 4, 5, 6, 7, 8, 9. So first last aldehyde, 8th one branch. So all you finished, 3, 4 finished. Just check down la. First and second. First one aldehyde, second one aldehyde. Totally 9 carbons, one branch. 1, 2, 3, 4 plus 3, 7, 8, 9. 9 carbons. So first aldehyde, second ketone. So correct one, C1. C1. Remaining is D. So D2. Option 2. A3, B4, C1, D2. So just take the IUPAC numbering for fast method. That gives correct answer. Okay. Next, rate of reaction versus time for zero order reaction. So zero order kinetics means R is equal to minus KT plus R under 0. R is equal to minus KT plus R naught. Y is equal to mx plus C. So negative slope. X time versus concentration of reactant. So negative slope, intercept of R naught. Option 2. Minus K. So direct graph only. Just R is equal to minus KT plus R naught. Next, 63. Bronze, copper, tin. Brass, copper, zinc. UK silver coin. Copper coated nickel. Stainless steel, iron, chromium, nickel, carbon. D block elements. Same list in the D block element chapter, same examples only. Maximum this type of memory, this memory based only, memory based questions are giving from the NCERT only. So you don't need to read the other examples which are not covered in the textbook. So textbook examples enough. Okay, so A4, B3, C1, D2, option 2. Next, identify the coordinate complexes in which central metal atom has D4 configuration. So look here, question is simple. So don't make it complication, means strong ligand, weak ligand combination given here. But we want only configuration of the parent, not after splitting or not after effect of ligands. So just take the configuration of the parent with respect to oxidation number only. FeO4 2 minus. X minus 8 is equal to minus 2. X equal to plus 6. Plus 6. So parent atomic number Fe 26, 4s2, 3d6, 20, 26. Plus 6 means loss of 6 electrons. 2 from s orbital, 4 from d orbital. So Fe plus 6 equal to 3d2. First one. Second one, Mn cyanide 6. X minus 6 equal to minus 3, x equal to plus 3. Manganese parent 4s2 3d5, but ionic form 3 plus. Here 2, here 1 loss, 3d4. So this is 3d4. Next one, x minus 6 equal to minus 3, x equal to plus 3. So that 3 plus means 2 and 1 loss. So Fe 3 plus equal to 4s0 3d5. Next one, chromium X, this acetate CH3COO minus 4 units, X minus 4, water 0, X equal to plus 4, chromium 24, parent, 4s1 3d5. Now requirement chromium plus 4, 1 plus 3 loss, 3d2 balance. Next one, nickel F6, X minus 6 equal to minus 2, X equal to plus 4, nickel 28, 4s2 3d8, nickel plus 2 plus 4 is equal to 2 plus 2, 3d6. 3d6 means 4 unpaired electrons. Oh, no, unpaired not. Only we want electrons only, not unpaired. d4. Oh, sorry. Here chromium 2 given, Cr2, 2x. X plus 2 charge. Plus 2 charge. Then chromium plus 2 charge only. Chromium plus 2 charge. Plus 2 means loss of 1 plus 1, 3d4. So 3d4, 3d4. Manganese and chromium, that is B and D. B and D. So B and D are having 3d 4. Option 3. Okay. So just only redox reacts type, just find out the configuration and find the configuration of the element D, not unpaired, not effect of ligands. Next one, 14th group elements, melting point. Carbon, silicon, germanium, tin, lead. Melting point decreases carbon to tin. Tin to lead increases. But lead is slightly more than tin only. Therefore, order equal to carbon more than, silicon more than, germanium more than, lead more than tin. Carbon, silicon, germanium, lead, tin. Lowest melting point means tin lowest, not lead. Lead slightly high melting point due to effect of inert pair effect. Inert pair effect because of lanthanide contraction effect. So contraction effect means nuclear force highly working. Nuclear force highly working, metallic bond strength increases. So lead is having strong metallic forces compared to tin. That's why melting point of lead is more than tin due to effect of lanthanide contraction. Metallic bond strength is more. Okay, now atomic number of tin. 6 plus 8, 14, plus 18, 32, plus 18, 50, plus 32, 82. So 50 is the atomic number of tin. Answer 4. If melting points, boiling points to follow order, values no need order, where is increasing, where decreasing for all P block elements. Next question number 66. pH of water is 7 at 25 degrees. water is heated to 80 degrees, pH will be H2O dissociate to form H plus plus OH minus. Temperature increases, degree of dissociation increases, more water molecule dissociate. Number of H plus ions increases and OH minus also increases. Then Kw also increases. H plus ions increasing, pH value decreases and pOH value decreases. That means temperature is inverse to pH. That is why we can take in general (25°C) pH equal to 7 for water, pH equal to 6, same water, that is called neutral pH. That means H plus ions increases, pH will decrease. Option 1. Next, 67. Compound AB following sequence. First compound is chlorine NaOH 623 380 m H plus. Nucleophilic substitution at high temperature. Direct not possible. Therefore, high temperature and high pressure requirement, nucleophilic substitution takes place to form A is equal to phenol. A is equal to phenol. Reaction name is called ARSN, aromatic nucleophilic substitution. Okay, and it is also addition through elimination. Addition through elimination. Addition of OH minus, elimination of Cl minus. Addition through elimination. Next one, phenol on oxidation. With sodium dichromate gives para-benzoquinone. Answer 3. This name para-benzoquinone. Next, consider a binary solution of two volatile liquid components 1 and 2. X1, Y1 are mole fractions of component 1, liquid phase, vapor phase. Liquid phase lo X symbol, vapor phase Y symbol for mole fraction. Slope and intercept of the graph, linear graph of 1 by X1 versus 1 by Y1. So, we have formula PT is equal to P naught A PA plus PB, PA plus PB, A suppose 1, B 2. P naught A XA plus P naught B 1 minus XA is equal to, on multiplication, P naught B minus P naught B XA. So, XA common, P naught B plus P naught A minus P naught B into XA. Or you want to write one more step, write 1 minute. One more step, write P naught A XA plus P naught B minus P naught B XA. P naught A minus P naught B, XA common. So, P naught B plus P naught A minus P naught B XA. Now, Dalton's law, PA is equal to Pt into mole fraction of A, that is called Ya. Therefore, Ya is equal to Pa by Pt. Pa value P naught A XA by Pt value P naught B plus P naught A minus P naught B into XA. Take reciprocal, 1 by Ya is equal to P naught B by P naught A XA plus XA cancel. Second part, P naught A minus P naught B by P naught A. But question given 1 by x1 versus 1 by y1. Multiply this formula with P naught A by P naught B. Then P naught A by P naught B into 1 by Ya is equal to this cancel 1 by XA, this is cancel P naught A minus P naught B by P naught B. You can take now B minus A, this minus. This taken B minus A. So this term taken in the right side plus. Then Y is equal to mx plus C. A1 to B1. So we want to slope first. Slope is A by B, 1 by 2, 1 by 2. And intercept value 2 minus 1 by 2, 2 minus 1 by 2. Option 1 more correct na? Option 1. Because in textbook we have in the many materials, we have formula this one, 1 by Ya versus 1 by Xa. But he even just modified 1 by x1 versus 1 by y1. So just multiply with P naught A by P naught B, use this side. Then Y is equal to mx plus C form. Okay. Next, a plot of root nu versus atomic mass is straight line. Mosley's law relation states that root nu is proportional to Z. Atomic number, use straight line. Not atomic mass. So this is a wrong statement. A plot of nu versus atomic number, straight line. Root nu, not nu. So both are wrong statements. So first one mistake is atomic number requirement, but given atomic mass. Second one root nu requirement, but it is given as only nu. So therefore first and second not wrong statements. Both false. Option 3. Next question number 70. Potassium dichromate in basic medium. If dichromate to chromate are interconvertible. Different medium. Chromate is orange plus 6 state. Dichromate is Cr2O7. Sorry. This is yellow, it is orange. Cr2O7 minus 2 is called dichromate. This name simply chromate because mononuclear, one chromium only. Dichromate converting into chromate. So, chromate into dichromate. This reaction in acidic medium. This reaction in the basic medium. That is why potassium dichromate or any dichromate not available in the basic medium. They are converting into chromates. Correct pH 7 maintain, neutral maintain, 50-50 present. 50% of chromate, 50% dichromate. So, here dichromate in basic medium convert into chromate. So, A is equal to chromate, potassium chromate, K2CrO4, color yellow. Next, addition of sulfuric acid, H2S4. So, this one with sulfuric acid, H2SO4, H2CrO4 plus potassium sulfate. This name chromic acid. This anhydride is loss of water, gives Cr2O3. CrO3. Okay. So, here small mistake is there because compound should be CrO3. Oh, sorry. A is equal to potassium chromate. Just again reverse conversion only. A again addition of acidic medium. Potassium dichromate. So, answer 3. Potassium chromate, dichromate, that is depend on the medium, conversion takes place, acidic medium, basic medium. But when the question given is chromic acid, this is potassium chromate in the presence of dilute acids, dilute acid, that gives chromic acid. Chromic acid on heating gives CrO3, that is Jones reagent. But a question not given as dilute acid, just only medium changes. That is why KOH, H2 means medium, taken as concentrated sulfuric acid generally, that is converting into dichromate. Therefore, B is potassium dichromate. Option 3. Next, 71. 0.01 mole of organic compound X containing 10% hydrogen on complete combustion produced 0.9 grams water. Molar mass of X is percentage of hydrogen is equal to 2/18 into mass of water by mass of compound into 100. %. 2/18 into 0.9 mass of compound not given, find out, into 100. So, 110 cancel, 9 cancel, everything cancel. Mass equal to 1 gram. Moles equal to mass by molar mass. 0.01 is equal to 1 by m. Therefore, m is equal to 100. Okay. So, just substitute the formula in the percentage of hydrogen. 2 by 18 into mass of water by mass of compound into 100. 10% H. 2 by 18. So, everything cancel. Mass equal 1 gram. So, moles given, find the molar mass. That is moles equal to mass by molar mass equal to 100. Next one, look, sequence of organic reactions. First one is aniline, NaNO2 HCl. So, we know it is a diazotization reaction. So, A is equal to diazonium salt. Okay. Next, phenol, coupling reaction. Phenol coupled with diazonium salt at para position in the basic medium. NaOH only medium purpose. Basic medium. But it dilute HCl hydrolysis because first it becomes ONA. So, let us sequence of reaction. Phenol plus NaOH C6H5 O minus Na plus. Now, this O minus into resonance, this bond comes here, this bond taken by para position. This para position undergoes coupling reaction with diazonium salt. That is equal to I will write OET this side, that side N double bond N attached to para position of phenoxide. Here one H is there, that forms into conjugation, then O minus. O minus is neutralized by HCl. But one small doubt here, ether also undergoes hydrolysis, acidic medium. So, to form phenol. But here number given, that is the important one. If number not given, we can take this also hydrolysis. That is nothing but OET also hydrolysis to form OH, phenol, because of hydrolysis in the acidic medium. Ethers undergoes hydrolysis in the acidic medium, there is no doubt. But count the number of carbon atoms. So, C14, that is 6 plus 6, 12 plus 2 in the ether. That is ether remains same only. So, that is compound B. N double bond N OH, compound B. Compound B now react with sodium hydroxide and ethyl bromide. Again phenol react with sodium hydroxide. NaOH, O minus, H plus, this replaced by Na. Next, the O minus react with bromide. That is OET. So, final compound C is equal to, this is constant only, ETO N double bond N OET, two sides ethers. then carbon atoms 14 previously, now 16, 2 more extra carbon, 16. Okay, how many sp3 carbon atoms in the sp3 hybridized carbon atoms? Ethyl sp3 only because single bonded. So 2 here, here 2, totally 4 because cycle is sp2. So here sp3, here also sp3, 4 only. Okay, so no confusion because the formula is given here. Formula is not given, then confusion is about hydrolysis of ethers. Okay, so first step once more is diazorization to form diazonium salt A. Next, phenol with NaOH. Phenol NaOH first undergoes phenoxide. Resonance stability to form O minus at C minus at para position. That will be coupled with diazonium salt to form diazobenzene. Next one, here H undergo rearrange into aromatic O minus. E O minus undergoes hydrolysis with LHCl. So, E dialysis purpose is hydrolysis of O minus. Hydrolysis of O minus into OH. Next step again NaOH, phenol become phenoxide. Phenoxide react with ethyl bromide to form OET. So sp3 ethyl only sp3, 2 plus 2 4C. Next, 81 gram aluminium react with 128 gram oxygen, mass of aluminum oxide, direct equation only, stoichiometric equation. Al plus O2 is equal to Al2O3. You can balance anyway because you can take 2, then 3, 4. 4 mole aluminium, 3 mole oxygen, 2 mole Al2O3. Stoichiometry. This is stoichiometry. But to given moles are 81 gram by 27, 3 moles. 128 gram oxygen, 128 by 32, 4 moles. This is find out. So, limiting reagent problem, 4 mole with 3 mole reacting, but reverse given, 3 mole, 4 mole given. So, you can take any one of them, first verification, aluminum suppose taken. For aluminium verification, 4 moles with 3 moles, then 3 moles with 3 by 4 into 3, 9 by 4 moles. Possible. 9 4 means nearly 2.1 moles. Possible. But to take oxygen base with respect to oxygen, 3 mole with 4 moles. Then 4 with how many moles? 4 by 3 into 4, 16 by 3, 5 point something. So, not possible. So, it is not possible because given only 3 moles. That is why limiting reagent is aluminium. Limiting reagent aluminium. So, reaction takes place 3 moles completely, here 9 by 4 moles reacting. To form 4 gives 2, then 3 gives how many? 4 gives 2, 3 gives 2 by 4 into 3, 6 by 4 moles. 6 by 4 moles or 3 by 2 moles. In terms of mass given grams. So 6 by 4 moles means 6 by 4 into Al2O3, Al2 54 plus 48, 54 plus 48, 102. So into 102 is equal to 612 by 4. One time 21 means 4 times 3, 153. 153 grams. So limiting reagent question is just first to verify the equation stoichiometry 4 3 2 stoichiometry. Given moles are 3 4, just reverse given. So here only possible we can compare here only 4 with 3, then 3 with less than 3 moles possible. This side 3 with 4 excess amount plus 1 amount, but 4 with 3 only given, not possible. So O2 is not a limiting reagent, aluminum limiting reagent. So excess is called O2 excess amount. So this is complete reaction, but we want only mass of aluminum oxide. 4 moles gives 2 moles, then 3 moles gives 6 by 4 moles into 102 molar mass. 153 gram is called mass of aluminum oxide. Next, bond dissociation enthalpy of X2 in the following steps. So this is a Born-Haber cycle, lattice enthalpy calculation. First find out direct equation, this is direct equation, and apply Hess law. Metal solid plus of X2 gas is equal to mx ionic crystal delta H equal to minus 400 kilojoules, all kilojoules only, no unit conversion. So each step name is called direct step. Direct step. Now indirect steps are metal solid to metal gas, first step. Metal gas into metal ionization, second step. This is plus S sublimation, this is plus I ionization. This is half mole dissociation, third step, D by 2 to form X gas. Electron gain enthalpy, fourth step, minus delta H Eg, that is X minus. Now these two ions combine to form crystal lattice. Energy releasing, because ions combine to form compound is energy releasing, minus U or lattice energy, Le. It is reverse given dissociation of the lattice. So delta H lattice, a lattice energy. Now the formula is delta HF, direct step, is step name delta HF. Direct step delta HF is equal to S plus I plus D by 2 minus delta H Eg and minus U minus Le, because it is formation. Substitute value minus 400, sublimation value 100, ionization 500, d by 2 not given, plus lattice energy value minus 800, sorry, electric gain first. Electric enthalpy value 300. This is plus of minus only. If I write like this, minus delta H is plus minus lattice energy. It is now reverse, minus of minus 800. So minus 400, 600, d by 2 minus 300 plus 800. So 3 cancel, remaining is 300, 8 plus 3 1100 plus 1100. So this is plus of Le, because as per same sign conventions, delta H S I d by 2 minus, this always minus, but this formula written as plus Le, depending on the Le calculation, if it is formation it is minus, if it is dissociation it is plus, but here Le value given here, not calculation of Le, that is why Le value given is minus 800, because it is taken as this direction. Le two types, formation and dissociation. So it is now formation, but given value is dissociation given. That is why minus 800 is equal to minus 1100. 1100 means 6 cancel, 500. So d by 2 is equal to 100, d is equal to 200, right. So delta H naught F is equal to S plus I plus d by 2 minus delta H easy, because this is always minus only, plus Le, formula is plus Le only. When question given, find out Le value in the formation of the compound, then answer is minus Le, put minus. If the question given, find out Le value for dissociation of compound, then answer is plus Le. So it is formula wise plus Le, but answer given as plus and minus depending on the formation or dissociation. That is why here plus into Le, but why given as minus 800 because in this equation we can take as formation, that is why taken as minus Le, minus 800. Okay. So if write minus Le, suppose, then the step taken as it is only, minus 800 only, don't write again minus of minus, minus 800 only. So d is equal to 200. Okay. Next one, compound X absorbing 2 moles hydrogen upon and X upon oxidation with KMnO4 H plus gives these compounds. First you attach these compounds to find out the parent alkene, because acetone, acetic acid, diacetone. So first I will take this one, 1, 2, 3, 4, 5, 5. CH3, CO. This is COOH. Because CH double bond CH on oxidation gives COOH, COH, H containing. CH double bond CC gives COOH plus ketone. That is principle of oxidation. Okay. So first compound, write full formula, CH3 CO CH2 CH2 COOH. Second one, acetic acid, acetone. Next, acetic acid. You can take anywhere only. Suppose you can take here acid, here acetone, because we want total compound only, not place of the double bonds. So, how many double bonds possible? So, here one double bond and here one double bond. That is equal to CH3 C double bond CH2 CH2. This is CH double bond CH. This is CH CH CH3, because this cleavage gives two acids. This cleavage gives ketones only, because both sides not having hydrogen. With H gives acid, without H gives ketone. So here no H, so ketones. You can take reverse also, you can take here also this one, take on that side. So total 2 pi bonds are present. So 2 pi bond means react with the 2 moles of hydrogens. And this is compound X. Question given number of sigma bonds present in the compound. Sigma bonds equal to total atoms minus 1. Total atoms minus 1. Total atoms means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10C. Hydrogens are 3, 6, 9, 11, 13, 14, 15 plus 3, 18, 28. So 28 minus 1, 27. So let us check the compound once again. If you do oxidation, again this bond undergoes cleavage. This ketone, this ketone. This gives acid, acid. That's why CH present two sides gives two acids. One side CH, one side no H, that gives ketone. So without H, alkene gives ketone. With H, alkene gives acid. That is principle of oxidation. Okay. So that's all. So in this also very normal average paper only. Just 2-3 questions, just small. That is one confusion is Born-Haber cycle. Light design is taken as plus Le, but depend on the formation or dissociation. Formation means minus Le. That's why minus 800 substitution taken. And this one is important mechanism, because oxidation of alkenes to form which compounds. And one more example is terminal alkene, last CH2, that gives formic acid generally, but formic acid is unstable, sometimes will undergo further oxidation to give carbon dioxide. Both correct one, formic correct one, carbon dioxide correct one. So generally they give as carbon dioxide, terminal alkenes, last one, because formic acid highly reactive, undergoes once more oxidation into CO2 plus H2O. Remaining all normal questions only. 2 questions memory based, that is colors and also number of unpaired electrons, that is also memory based questions, that is dependent on NCERT only. So what are memory based questions? Those examples from the textbook itself, that is brass, bronze, copper, German silver, all these examples in the textbook given, follow textbook examples. Extra examples no need to cover, that is memory based questions. Okay. Remaining questions are organic chemistry part on normal only, not very difficult. So wherever the confusion present to hydrolysis, not hydrolysis, that is question given as ether with HCl undergoes hydrolysis actually, but question is given as with the number of C. Number of C given means there is no confusion present here. Okay, thank you.
Brilliant Study Center, India's #1 coaching center for NEET and JEE.